Welcome to Mathy Python, episode 10. These are solutions to the problems on functions. Problem 1, write a function greet name that prints hello Bob or whatever the name is. Test it using a few other names. So I wrote a function. DEF is for define. Why they didn't use function or something else, I don't know, but anyway, it's DEF. So define the function, which is greet, and then I will take the parameter name and print with an F string hello, and then since it's an F string, name is considered a variable. It's in curly brackets. Okay, and then for fun, I looked up the most popular baby names of 2026. Had agreed Olivia and Hoa and Amelia and Liam and Aliana and Oliver. Number 2, write a function is even. It returns true if n is even, false otherwise. Test on 0, 1, 2, -3. So the function is even. You just return n mod 2 equals 0. So this has a double equal, so it's asking the question, is in mod 2 equal to 0? If it is, it's even. If it's not, then it's odd. So if this is true, it returns true. If it's false, it returns false. So you don't need to check if this is true, return true. If this is false, return false. Just return it. And then I try it on these numbers, is even 0, 1, 2, -3. And when we get true, 0 mod 2 is 0. That's true. So under this definition, that's okay. Is even 1, false. Is even 2, true. Is even -3, false. Number 3, write a function Celsius to Fahrenheit and a separate function Fahrenheit to Celsius. Verify they are inverses of each other by converting 100 degrees Celsius to Fahrenheit and back. So I define the function Celsius to Fahrenheit. It takes Celsius, plugs it into a formula, returns to Fahrenheit. Another function that's Fahrenheit to Celsius, takes the Fahrenheit, returns Celsius. Then F is Celsius to Fahrenheit of 100, print it out, it's 212, that's boiling point of water. Convert it back, do I get 100 back? Yes, I do. Number 4, write a function circle stats radius that returns both the area and circumference of a circle. Test it on a circle with radius 5. So I import math because I'm going to use pi from the math module. Define the function circle stats of some radius. The area is pi times that radius squared, rounded to 1 decimal place. Circumference is 2 pi times the radius, again rounded to 1 decimal place. Return both of those, area, circumference. Try it on a circle with radius 5. I get 78.5 for the radius, 31.4 for the circumference. Number 5, what's wrong with this function? Fix it. So I define a function, add a and b, result is a plus b. Then I print add 3, 4. This won't work because it doesn't return a value. So if I try it, I get none. That means that when the function is called, it does not explicitly return anything. So Python indicates by having it returned none. If you're expecting a number, you'll be disappointed with that. And the solution to that is make sure you return when you want to return. Having said all that, it is possible to have a function where you just print something and it purposely doesn't return a value. So I could say print result, have a function, add 3, 4, and now it prints it. But if you wanted to do anything with that 7, then it's gone. It printed it and it's gone. Number 6, write a function. Power takes base and an exponent. By default is 2. If you don't pass in an exponent, it'll take a default value of 2. And this function returns base raised to the exponent. Call it 3 ways with both arguments with only the base and with keyword arguments in reverse order. So there's our function defined. It returns the base to the power of the exponent. And then I print some things out. Power 10, 3. The parameter of base is 10. The parameter for exponent is 3. That's overwritten the default of 2, so I get 1,000 with 3 zeros. But I say print power of 10, base takes on the value of 10, exponent is 2 because I didn't pass any. And because these because the arguments have names, I can name them when I pass them in. So if you have a function that has many arguments, you might not remember what order they're in, so you can just say what the name is. So matplotlib, for example, has a lot of these for plotting functions. They have a million arguments, but you don't need to memorize what order those are in. You just call it by name. So in this case, power exponent is 3, base is 10. So I switched the order, but I gave the name, so it still understands it. And I get 10 cubed, which is 1,000. Number 7, write a function summarize numbers that takes a list and returns a dictionary with keys, minimum, maximum, sum, count, and mean. Route each stat to 2 decimal places. So I write the code to summarize the numbers. Minimum is a large number, maximum is a small number, total is 0, count is 0. Iterate through the numbers of the list that were given. Calculate the minimum, the maximum, the total, and the count, and the average, the mean average. Then the result is the minimum, and I round the minimum that I found from this to 2 decimal places. And the max, I round the max that I found in lines 10 and 11 to 2 decimal places. Similarly, for sum, count, and mean, return the result. Feed it a list of numbers, call it to summarize, and we see that we get a dictionary with the minimum, max, sum, count, and mean. Number 8, write a function is palindrome that returns true if the string is palindrome. Ignoring spaces in case, test it on some test cases. Is palindrome the function? Takes an argument s. S, I will replace spaces with nulls, so that gets rid of the spaces, either at the ends or in the middle of the string, and then convert that to lowercase. So we can daisy chain these methods together, which is nice. So you can do all that on one line. And then return, is the string equal to the string in reverse? So that's asking the question, is that true? It'll return true or false. And then print the results for 3 cases. So race car, a man, a planet, canal, Panama, which if you make it lowercase and take out the spaces is a palindrome, and then math Python. So you get true, true, false. 9, write a function, compare lists, list 1, list 2. Name 1 by default is list 2, list 1. Name 2 by default is list 2. And this function takes 2 lists of numbers and prints out a formatted comparison table that looks like this. The hint is to reuse an earlier problem. So we compare lists, list 1 and list 2. S1 is summarized list. That's from problem 7. No reason to rewrite that code. We already did. S2 is a dictionary that has the summarization of the elements of list 2. Then I print it out using some formatting. So the column width is 12, the label width is 8. Then print, the space that has 8 characters and it is pushed to the right. The name 1 is whatever you want to call this. Here it's morning and afternoon. And give it its proper formatting. And then, write the extract values from the dictionaries and write them in the table properly formatted. So we try these two lists of numbers, one morning, one is afternoon, presumably temperatures in Fahrenheit, then call the function and it prints out that table. Number 10, in Python, you can pass functions into other functions. So write a function applied twice that takes a function and a value and applies the function to the value twice. Test with Celsius to Fahrenheit from problem 3 and the starting value of 0. So here I have applied twice. I'm passing in a function I'm calling f. The result is f applied to x and then f applied to whatever that is. And that's our result. So if we apply twice Celsius to Fahrenheit of 0, 0 comes in. We'll get 32, pass 32 back in, and it comes out to be 89 points. Problem number 11 is Newton's method. Write a function, square root Newton of n with some tolerance that computes the square root of n using Newton's method. And that method does start with a guess of n over 2. Then repeatedly update the guess using guess is replaced with guess plus n over guess, and all of that divided by 2 until the difference between successive guesses is less than the tolerance. Compare your result to math of square root of n. So I import math, I write the function square root of Newton. So n tolerance is 1 times 10 to the negative 6, very small number. So that's our epsilon, basically. So guess is n over 2 initially. Previous is that guess. The difference, I don't want it to kick out of the loop immediately. So I'll say it's the tolerance plus 1. And then look at while the difference is greater than the tolerance, it'll compute. So then when it's less than equal to the tolerance, it'll kick out of the loop. Previous is whatever the current guess is. The guess is replaced with with this formula. The difference is the absolute value of their difference. And then it goes back in the loop until that difference is greater than the tolerance. Then I return the guess. And then we print it out. So we use print formatting, formatted strings to print out this table. We look at the numbers in turn, so 239, 2.25, so forth. And we see Newton is not bad. It's pretty close. It's spot on, many of these. Yeah. And the difference is just tiny. So the method is working very well on our test set. Number 12 is function composition. Write a function, compose fg value that returns a new function that applies g first, then f. Tested by composing Celsius to Fahrenheit and Fahrenheit to Celsius. The result should be the identity function. So it undoes, the functions undo each other. So the result is the identity. So I compose a function f, a function g, and a value, and I return. We read this from the inside out. So g of whatever that value is, that in itself is a value. Then f of that value gives us yet another value, and then we. So if we compose Celsius to Fahrenheit and Fahrenheit to Celsius of some number, we should get that number back, the identity of that number. So first it converts 212 to Celsius, and then that converts that back to Fahrenheit, and we get 212.